Yeah, hi everyone. So today we are going to do this easy level problem. So the problem, so this is a question you can go through it. So we are given an array and we are given a direction. So you can pause this and go through the question. So I'll be explaining the question what they want. So here they are given an array having positive non-zero integers called buildings, and then we are given the direction, which is either east or west. So this actually represents buildings of different height, and we need to return an array of indices of the buildings that can see the sunset. So we need to return buildings which can see the sunset. So what do they mean by seeing the sunset? So a building can see the sunset if it is strictly taller than all of the buildings that come after it in the direction that it faces. So the direction facing is given by east or west. So and the direction is either east or west. So in relation to the input array, you can interpret these directions as right for east and left for west. So what they mean is, if we have this array and if input is east, so it means this is east, since right means east. See here they're telling we can interpret this direction as right for east. So right is east, left is west. So now since in our case it's given east, so here are the buildings in representation. So we should so all the buildings are facing this side towards east, so towards this side. So as per the question, a building can see the sunset if it is strictly taller than all the buildings that come after it in the direction that it faces. So the direction that it faces is east, and then a building can see the sunset if it is strictly taller than all of the buildings that comes after it in the direction that it faces. So the direction that it faces is east, and it can see the sunset if it is strictly taller than all the buildings ahead. So for example, if this is the direction all the buildings are facing, so this this three building number three can't see any sunset because five is blocking. So three can't see, three is out. So this is this is zeroth index. This is the first index. So five is can be seen. So we add five to the result. Index of 5 is 1, so 1 is added, and then we come next. So 4 is again blocked. For this one is again blocked by this building. So this one can't see. So 2 can't see. Building at position 2 can't see. Next we look at 4. So 4, there is no building taller than 4. So this one can see. So index 3 can see it. Next, coming to the fourth index. Can three can can this building see the sunset? No, because this one is blocking. So this one also can't see. Fourth index also can't see. Next one anyway can't see because the third index is blocking. The building at the third index is blocking. Next, three three can see the sunset because there is no building to the right which is taller than three. So six can see. Next, two, seven. 7 can see because there is no building ahead of the building number 7. So 7 can see. So this is the output, but then they want that the indices must should be in sorted in ascending order. So we need to reverse this one. So after applying the reverse function, we get um, it's- wait, it's already in ascending order, so we don't need to do anything. So so yeah, so this is how we find out. At the same time, if this was west, so if this was west, if the input was this array and the input was west, so the buildings would have all been facing this direction. They would all be facing this direction. So coming back to the question, a building can see the sunset if distinctly taller than all of the buildings that come after it in the direction. So this one is facing this side and it can see the sunset because there are no buildings after this position. So the result would be, I'll just keep this one aside. So this one is for east. Okay. So now for west, the result will be, I'll just move this. Okay. This one I'll make it come here. So next. So now it is facing west. It's facing west like this. So buildings are facing this side to the west. So now the result will be, can building at zeroth index, can the zeroth index see the sunset? Yes, because there's no building after this index, so it can see the sunset. Next, so next it comes to index number one. So this one is more taller than the zeroth in the building at the zeroth index, so it can see the sunset. And next, if we come to building index 2, so for building index at 2 can't see the sunset because 5 is taller. And next we come to here building index 3. 3 is again, this again it can't see, building index can't see the sunset because 5 is blocking. And then building index at 4, which has a size of 3, can't see the sunset because the building at number 1 is having a size of 5, where is greater than 3. And then building index at 5 can't see because it has a size of 1 and 5 is greater than 1. So on. So like this, so this is the answer. So we need to add the index, not the actual building index size. So I'll just add the index. So this is how we have to do it. So answer is 0 and 1. So if we can check it, so it is 1367, 1367 when it is uh, east, and 0 and 1 when it is west. So this is a visual representation and the solution, like how we have to do. So there are two ways to do this. In fact, there are many ways to do this one. So the brute force approach of finding the index would be like, if it is east, right? So if it is east, okay, all the buildings are facing east. So so what is the brute force solution? So we now have something called, we'll now keep something called uh, max height. Hmm. So now we keep a check of the max height. So we start from here, that is the zeroth index. So if we so max height is initially 0. Okay, so now we have the value 3, so max height will become 3. Sorry, max height will store, yeah, so max height will store the 3 and next we'll have the result. Yeah, so initially max height will be 0. So now when we come across the first element, first building, it will have a max height of 3. So we will be storing the max height 3 over here, and no, okay, max height will be pointing to the very first element. So max height will not be having 3. I mean, it won't be having 0. Max height will be having 3, right? So if result, so now we started treating. So we started treating from here. So so now since we are going in the eastward direction, we'll start iterating from here. So 5 is greater than 3. So yes, it is greater. So we will store the index 1 and the max height we will put it as 5. Okay. Next, next from, okay. So next, if this is 5, we will store 1. Okay. Next, we will come to index 2. So we need to check for any building which is greater than 4. So it is, this one is equal to 4, this was lesser than 4, lesser than 4, lesser than 4, so we do nothing. So next we come here to index 3. So when we come to index, wait, do this again. So initially we assume the max height as 3. So we check for anything which is greater than 3. So so we start from this one. So 5 is greater than 3. Yes. So max out will put it as 5. After that, this index 1 will put over here. And next we come over here. Okay. When we come, uh, when we come here, so we will assume max height to be 4. So we need to find any index which is greater than 4. No index is greater than 4, so we don't do anything. So next we come to this third index. So third index we will have max height as 4. Yeah, so let me start this one. Okay, so the brute force approach would be to check is to start from here. Okay, need to start from here and check if a number is greater than or equal to this building. So if there exists, then this thing can't see the sunset and we break. So for example, we start with this one. So maximum height is 3. I mean, just leave this. So the height is 3, and then we check for a number which is greater than or equal to this number. So there exists a number which is greater than or equal to this number. So this thing can't be added to the result. So next we come to the next iteration. So we come to this one. We check for a number which is greater than or equal to this building height. So there exists no number which is greater than or equal to this building height. So we add the index 1 over here. So next we come to this index. We check for a building which is greater than or equal to the building size 4. So here already we found it. So we break. So this can't be added to the result. So next it can't see the sunset. So next we come here. We check for a building which is greater than or equal to 4. Yes, there exists a building which is there exists no building which is greater than or equal to 4. So we add 3. After this, we check for 3. So 3 can't be added. Next one can't be added. Right? And next we come to 3. We come to index number 6. So this thing can be there exists no number which is greater than or equal to 3. So we add 6. And next we add 7 because there exists no building which is greater than or equal to 2. So this is it. This is how we got the results. So this is the brute force approach. So for this one, it will be time complexity will be n square because for each and every index we are iterating through the whole array set, all the indexes. So for this one we iterate through all the indexes. For this one we will iterate through all the indexes. So we are going through the whole thing twice. So time complexity will be n square, and next space complexity will be O of n. I mean space complexity will be O of 1 because we are just returning one result. So we are not taking up any more space. So space complexity will be O of 1. Okay. So yeah, so this is the brute force approach. Space complexity space complexity will be O of n because we are storing, worst case we might have to store all the integers, all the building sizes. So yeah, it will be O of n. So this is the best. So this is the uh, brute force approach. So now is there a so there is a much more better efficient way to resolve. So what we do, so the trick here is we need to start iterating from the, so if it is east we need to start iterating from the right side. So when we are iterating from the right side we will have something called max height. Okay, so if we are iterating from the right side, since it is east, we need to iterate from the right side. So we will keep max height as 0 initially. So when max height, when the building is greater than the max height, right, we we will create the results. So when the building is greater than the max height, we change the max height, so it is 2, and then we add the index to this one. So now max height is 2, so 3 again, max height will now be 3, and next we add this index over here. So next one, 1 is not greater than 3, so we don't do anything. 3 is not greater than 3, so we don't do anything. 4 is greater than 3, yes, so max height is 4. We add the index over here, 3. Next, max height 4. So next we come to 4. 4 is not greater than 4. Next, 5 is greater than 4. Yes, so max height will be 5. And this index will be 1. Next, 3 is greater than 5. No. So we 3 is not greater than 5. So that's it. So this is how we get the answer. So, but for this one, what they say is in the question, we have to have the thing in ascending order. It should be in ascending order. So we just need to pass it through one reverse function. We get 7. Sorry, we get 1, 3, 6, and 7. This is it. So this is how. Sorry. So this is how we solve the issue. This is how we solve the problem. So we take from the right side. So in case it is west, okay, all the buildings are facing. If it is on the west facing, okay, all the buildings are facing this side. So if it is east, we started from here. So if it is west, we'll start from here. So max height, I'll write it here. Max height, and this is the result. So max height is equal to, so we start with 0. So max height is 3. We add it to 3, and we add 0. And next, max height is 5. Yes, 5 is greater than 3. We add 5, and then we also add the index. And next, 4. 4 is not greater than 5. We don't do anything. 4 is again not greater than 5. We don't do anything. Next, 3. 3 is not greater than 5. We don't do anything. And 1 is greater. 1 is not greater than 5. We don't do anything. 3 is not greater than 5. We don't do anything, etc. So in the end, we'll get the result as this one. So this is the approach. What we are going to do. So now let's do the coding. So there are many ways to do this coding. So if you want, you can do it like this way. So yeah, you can do it like this in the first approach. So if direction is east, so you start iterating from the right side. Okay, you start iterating from the right side, you collect the result and give. Next, again you write the same thing again. If direction is west, you just iterate from the starting, and then you return the result. So but here we are like copying. That is, code is quite verbose because the same thing we are having the double amount of code. So if it is east, we will be having this, and if it is west also, we'll be having the same similar type of code, right? So for that, there is one small trick we can use. So let's see how we can solve both the cases in one single loop itself. So for this solution, so for this solution, it will it will be time complexity will be O of n, and the space complexity will be O of n. So time complexity will be O of n because we'll be treating only once, and space complexity will be O of n because we are storing the array. So yeah, so let's see the trick. With one loop only we can do it off. So we will declare int, we will declare a result. So let's list integer result is equal to new array list. Okay, after this, uh, after this, we will int start index is equal to 0. Int step index is equal to 1. So and if direction dot equals west, what we do is if direction is west, if direction is east, if direction is east, we put start index is equal to building start size -1 and step index is equal to this one. So next, so after this, we will just declare one index int index is equal to start index. So here we need to keep iterating, and we need to stop only if so id x must be greater than or equal to 0, and idx is be lesser than buildings dot length. So these are the two conditions. So I'll first initialize int max height is equal to 0. So if max height is greater than building of idx, if max height is greater than buildings, so what do we do? max height is greater than building, if building ADX is greater than max height, result dot yeah, the result. And next, after adding the result, we change max height is equal to max height is equal to buildings 5dx. Update max height. Next, after this, we do idx is equal to step index. So it will go up or down depending on this condition. Idx is equal to idx plus step index. So this is how it is. So if if we go in the east, we'll get it reversed. So if direction is, let's put this. So we reverse it. So result. Compatible time list of integer cannot be converted. Okay, so guys, so this is the output. So this is part 1 of the video. So time complexity will be O of n, space complexity will be O of n, because like I explained, we're rotating only once and we are not storing, and we are storing and in the worst case we have to store the entire array input as the output. So space complexity will be O of n. So we can solve this in one more way by using stacks. So that I'll explain in the part 2 of the video. So please check that out. Thank you for watching.